Hello everyone. Welcome to today's webinar. I see that people are still joining, so we'll give them another minute to complete their login. It's also a chance to get comfortable, clean any distractions, and be ready to listen for today's webinar. So I think that we're just about ready to start. So welcome everyone to today's webinar about managing applications SLA in the multi-cloud era. I know that application SLA has always been a challenge that many organizations had to deal with. I think that most of the organizations have already seen the importance of that and managed to also address this challenge. However, moving to the cloud, the transition to the cloud is posing new challenges in this area of managing the application SLA. It's no longer managing an application that resides in your own data center. And there are some challenges that needs to be addressed. We'll cover them today, and we'll also suggest few ways on how to handle those challenges the best way. So before we start, let's see what are the challenges that actually IT managers see according to a dark reading survey. And they said that 95% of respondents said that visibility problems caused applications or network performance issues such that were perceivable by the end users. So we all know that performance issue can affect productivity, can also affect the loyalty of customers to your website, their decision factors. So this is a critical issue for most organizations. But not only that, actually insufficient visibility, according to 38% of respondents, insufficient visibility was a key factor in applications outages. The fact that they didn't see a problem being created, they didn't see a problem rise in their applications, also caused some outages to parts of their applications or all of their applications, according to the survey. Another important factor, especially today, to take into consideration, and that's also according to 87% of respondents, they claim that lack of cloud visibility is obscuring security threat. The fact that they were not able to monitor attacks on their applications, to monitor attack on their infrastructure or the cloud infrastructure in general, also led them to see a security threat taking place on their applications and services that they provide online. So all of those are definitely challenges that most organizations would be concerned about today. Why is this a problem? Why is this a new problem when we move to the cloud? Well, if we take a look at the standard or the old paradigm where an organization had a data center, in their data center they had the underlying infrastructure, which included the compute, included the storage, included the network infrastructure, the security infrastructure, everything as an infrastructure. And on top of that, they would deploy their own applications. What we see is that it was very easy for them to manage the SLA, to monitor and manage the SLA inside their data center. It was all under their jurisdiction, all under their own responsibility. And even then, by the way, I've talked to quite a few customers. They always had this constant fight between the application owners and the infrastructure managers, the network managers, where each blamed each other for the slow response time on a certain application or another. But still, they were still working on the same organization. They could still go into the same room and discuss the problems and assign responsibilities accordingly. However, when we move to the cloud, there's a separation between the underlying infrastructure, which is the cloud provider's jurisdiction, and the applications that are deployed in the cloud, which is the business owner's jurisdiction, the organization jurisdiction that is actually moving application and workloads to the cloud. And between them, there are multiple availability metrics that the cloud provider might provide. And this is creating new challenges, and basically we are using a new responsibility model, a shared responsibility model between the underlying infrastructure and the applications, between the cloud provider and the business or organization. And now suddenly the organization is dependent on the SLA management tools and metrics that the cloud provider provides him. The ability to aggregate information from the different jurisdictions. So for example, if I want to manage an SLA of my application, I need to understand whether my servers have good health. I need to understand whether the application itself is running okay and provides reasonable delays, or maybe some transactions are not performing well. We don't know if it's due to an SQL server, an SQL service from the cloud provider, or is it because of the application itself. And we need to do or provide tools to monitor this SLA for all the applications that we deploy in the cloud in an automatic way, because if I need to develop a new tool for every application, this is also going to be a big challenge for organizations. Now, this is when you use one cloud provider, but imagine what happens when you're using multiple cloud providers, which is the case for most of the organizations today. Now, each cloud provider provides you with different tools for SLA management. He provides you different availability metrics. He provides you different KPIs. All of those are actually new challenges that even make the problem or the challenge of managing the SLA of applications in multi-cloud even more complex. So what do you need in terms of visibility? It doesn't matter where your application is deployed, in the cloud, one cloud, the other one, your own data center. But basically what you want is to see the overall user experience, to be able to monitor the overall user experience, like delays, like availability of the application of the service to the end user. The second thing, for example, you need to monitor per application transactions. So each transaction, there are different types of transactions, like the login into your application. Is that function working properly? Maybe browsing on your internet site, maybe browsing on your online shop. That's another type of transaction, and maybe do the actual purchase. That's a third type of transaction. You want to see the performance on each and every transaction and to understand where your problem in the chain resides. And of course, you want to see per location, per device, per browser type, the performance of your applications and services. There are many parameters, and I only gave a few examples here that are actually related to the application, and all of those parameters are basically application monitoring. And this is quite easy, regardless of where your application resides. Those are the types of things that you are going to monitor, and in most cases, many cases actually, the application monitoring is actually embedded in the application, or maybe it's an external service that you're using, but with integration to your application, regardless of where it resides. However, there are some additional parameters that you want to take a look at. Like, for example, are there any attacks on your applications that are affecting the SLA? Are there any attacks on your application that are actually compromising the security or the integrity of the data that you store on your customers, on your employees? Maybe there are attacks on the infrastructure that impact the SLA of the applications. And basically, this is the ability to monitor cybersecurity parameters for your services. Now, when you're in your own data center, again, you build your solution, you own all the components, it's easier for you to monitor cybersecurity parameters. But when you move to the cloud, this is becoming even more complex in the cloud. Last but not least is the ability also to monitor the infrastructure. For example, monitoring the health of your application servers, or maybe monitoring the health of the network, or maybe monitoring the health of the internet connection. And this is basically monitoring infrastructure health. And again, this is owned by the cloud provider, and usually this is not an easy task. And for each cloud provider, you might have a different API for doing this monitoring, different KPIs, and different metrics that a cloud provider might provide you. So getting basically an SLA solution that monitors those three areas, those three components for providing the applications and manage the SLA of the application, integrated into one, providing a single pane of glass throughout the different environments in which you operate. This is a huge challenge for many of us. So take, for example, an organization that has applications in AWS, in Microsoft Azure, in the Google Cloud. the goal basically is to have one central pane of glass. But in a new paradigm, now that you're moving to the cloud, the way of operation is also completely different. You don't have anymore an IT administrator that manages your compute. You don't have an IT administrator that manages your ADCs, for example, the network, and then the application owner. Basically, it's the application owner that runs into the cloud, maybe the DevOps that develops all the automation for putting a new application in the cloud, and they are the ones that need the monitoring now. Okay, so everything needs to be done in an application-centric way so that the application owner can easily monitor the health of his applications and understand, because there's no other person to approach if you have a problem in the underlying server. It's the cloud provider, but then again, you need the ability to monitor the health of the underlying server on which the application is deployed. So you need to make everything simple and intuitive with a single pane of glass for all the environments in which these applications are actually deployed. Last but not least, the best wishful thinking here, or the best wish here to have, is also to have a closed loop. So for example, if you identify a problem in your application, an SLA problem in your application, to suggest some suggestion on how to fix that, and maybe also create some automation around it, so that once that you identify a problem, it can launch a wizard that will help you, let's say, for example, reconfigure your application delivery controller so that it will be able to address the SLA breach that was created. We've seen a request from many organizations, or actually a recommendation for many organizations, to standardize their operation across the different environments. So for example, if you work in AWS, Microsoft Azure, and Google Cloud, the best way to provide a consistent SLA monitoring solution across those different environments is to standardize the solution. Okay, that shouldn't always be as trivial as it sounds. But having a single solution for all of them would be the best way to provide a single pane of glass with insightful reports and actually intuitive reports that will allow application owners and DevOps to really monitor their applications in those different environments. So what we found out in Radware, and actually not only us, some other ADC vendors have found out the same, is that the application delivery controller is the best place for monitoring application SLA. And let me give you some examples on how this is so. First of all, the application delivery controller oversees all users' requests and all server responses, and basically can measure the application response time, for example. It can measure the server response time, it can measure the network delay to the user, and it can measure the overall completion of a transaction on the user agent side. So the ADC is basically the best place to monitor the different component of the SLA chain, or of the SLA of an application. Not only that, the application delivery controller by nature monitors also the health of the application resources. So for example, it does monitor the server's health. Some application delivery controller can also load balance between multiple WAN connections, so internet access connections, and also monitor the health of each internet connection, and also load balance across them according to the health of each and every resource, and also load balance to those directions. So if the application delivery controller could also aggregate this information and push it into a monitoring service, that would help the most for organizations and application owners basically to get all the information they need in order to manage their application's SLA. So The ADC is the best choice for providing visibility into your application's performance. This is the best location in your network to collect all the information in an aggregated way and provide it to manage your SLA. And ADC standardization also is in the heart of standardization of SLA management solutions across different environments. Let me give you an example of what Radware is doing. Let me give you an example of what Radware is doing basically in that sense to provide a solution that can work across different environments, your local data center and some public clouds like AWS and Microsoft Azure. So in the center, basically, we have a controller, Alteon Cloud Control, which can spin up application delivery controller virtual machines in the different environments, application delivery controller services for different applications in different clouds. And basically, it's a centralized solution with one ADC technology that is the same across the different cloud environment, across the different data centers environments. So we don't care if you're only using virtual machines, if you're using physical ADCs in your local data center, if you need it on Microsoft Azure or AWS, you have the same ADC technology with the same visibility technology for all. So basically, all of the ADC services that we deploy across the different environments can report back to the analytics module that resides inside the Alteon Cloud Control, inside the central controller, and aggregate the information from the different ADCs, from the different applications, from the different environment into a single pane of glass, a centralized one, and provide it in an application-centric way so that each application owner will be able to monitor his own application and quickly understand if one of his applications has a problem, and to also do some root cause analysis that will allow him to identify where the problem resides. Is it on one of the servers, on one of type of transaction? Is it a problem of an attack? Is it a problem of infrastructure? Is it a problem of an application? Now, instead of going forward and showing you additional slide about what the solution does, actually, let me show you how the solution really looks like in real life. And based on that, you'll be able to understand what a possible solution in a centralized manner like the one I'm showing you here can really work for you and help you manage your application's SLA. So let's start the demo very quickly. This is a live demo on a system that is actually deployed in the cloud, specifically in the Microsoft Azure cloud. And in this demo, we have the Alteon Cloud Control as a centralized system that collects information from different ADC services that are deployed in different regions. Let's go quickly to the environment dashboard to see which applications are deployed, which ADC services are actually deployed, and collecting information on the health of each application. And what we're seeing here is basically a quick status, 100% status, for example, on the health of the ADC that is actually doing the application delivery services for the applications that are running. So we have a multi-cloud demo, we have a Radware demo, and here we see, for example, 2 ADC instances that are deployed in a cluster for the Radware demo. Okay, and we have Radware demo 1, Radware demo 2. Those are the 2 ADCs. You can see the instance score of this of its health. We can even deep dive and see exactly what is the health of each application for the last 15 minutes or for the last hour, as an example. Okay, so we can see the throughput rising in the past hour. We can see that the CPU utilization is very, very low. The number of instances was 2 along this hour. The health score remained at 100% along the last hour. Okay, so we can see exactly how many active instances, provisioned instances, memory utilization, throughput, etc. So we can also deep dive into the application SLA monitoring itself and have more information about the application health parameters. So let's go into the application dashboard. And in the application dashboard, I see all the applications that I specifically own as an admin in sales hardware. And we can see in a glance the list of applications, and we can see in a glance the health score that each application has, 84%, 99%, and let's find out exactly why. In this case, for example, the performance is 99%, meaning some transactions might have completed too slow. The availability is still 100%. The system is still 100%. So we know that we have some performance issues. The same for the second applications. We can see for each applications how many servers do we have deployed. So we're load balancing here about 4 different servers. All of the servers have 100% score. So that means that all of the servers are healthy and that the ADC is actually load balancing traffic to all of them. And we can also deep dive and get some additional information for each of the applications. Let's go into the detailed report here. And what we can see, for example, is that the average response time that we have for that applications on all of the transactions in the past 15 minutes has been 81 milliseconds. We can see the historical throughput, which is very low, the number of concurrent connections, requests per seconds, whether they are HTTP 1, HTTP 2. We can see also the historical response time for that application in the past 15 minutes. Okay, but it doesn't end here. We can also deep dive and get a per transaction report. So what we're seeing here are the transactions that have completed in the past 15 minutes, which is very nice. This is an application that is running on and off in the past months, so it's not very interesting to see what we have in the past 15 minutes. But let's take a look at what was happening in the past months on a per transaction level. Now, it's not really interesting to go and deep dive into each and every transactions. You might have millions of them. But it's very interesting when you're grouping different types of transactions. So for example, I can ask the reporter to only show me transactions that have completed with exceptions. Okay, now I can see that there was one time that we had a huge number of exceptions at around February 22nd, 1,000 exceptions. I can ask it to actually deep dive into this specific time frame. And see what were the reasons for exceptions here. And the reason was response code 4XX, 400. And basically, usually when it's 400, it's because that someone is trying to access pages that are either not available or pages that do not really exist. And if I take a look here, someone is trying to access a URL, for example, that is admin URL. Now there's no admin URL in this application. It's a very basic server that only shows a page that says this is a demo application, and there's no reason for anyone to really go and take a look at this application unless he's part of this demo. Now we can also see the list of locations from which this application was accessed and completed with a 4XX response code. And we see that most of those transactions, about 92% of those exception transactions came from China. It already raises a suspicion that this is a kind of a hacker that is trying to access my application and finding a loophole. I can filter specifically the transactions that came from China. And I can now start and take a look, for example, on what is the OS that was used, 4 different OSs, like Windows, Linux, Ubuntu, and others. From 4 different types of browser, Chrome, Internet Explorer, Firefox, and others. We can even deep dive into those specific transactions, and we can see also what is the average response time. Now, because the page didn't exist, the response time here was almost 200 milliseconds, but we can also find out about transactions that completed in a too long of a time. So this is one way to pinpoint on a problem. Let's remove the filter completely and still see what happened in the past months. And let's see how many transactions, as an example, ended with an end-to-end response time that was above 800 milliseconds. Okay, so I can ask it to filter only those, and now to start and deep dive into those transactions and understand what is the reason that this transaction completed in such a high response time relatively. So we can see that the location in that case was Israel. Maybe there was a high latency in the internet connection between Israel and the cloud in West Carolina, in which it is deployed in Azure. This could be one reason, but we can see a lot of information here about the transaction in order to understand that. Okay, so what I'm trying to show you here is that you have a very strong reporting tool that collects information about each and every transaction and then can group them all together in order to understand what is the reason for an SLA breach, and to assign the handling this SLA breach to the right team, whether it's an attack on my application, whether it's an infrastructure problem with which I need to resolve it with my cloud provider, or maybe it's a problem with one type of browser, one type of transaction. In that case, it could be a problem of the application. Okay, and I can clean the filter again and get all the information back to start my RCA, my root cause analysis from the beginning. Okay, now each application owner in this case receives his own screen of application dashboard where he can see his specific applications that he needs to manage. The Alton Cloud Controller, of course, does a lot more than just monitoring the SLA of application. It also helps you provision and manage your application services, but this is a separate topic for a separate webinar. So let's summarize. Managing the SLA in a multi-cloud era actually requires some standardization. Otherwise, you'll end up with different solutions for different environments, and each application owner and each application in a different environment will have its own monitoring tool. This could be a nightmare, and actually, I believe that if there's no standardization, basically an application owner would rather to skip a lot of the ability to monitor his application and manage the SLA of his applications. Okay, we need to provide one single pane of glass to be able to monitor all applications in all environments from a same monitoring tool. It must be a DevOps and app owners friendly. So everything that we provide needs to be app centric. I don't care if we need to provide information about the infrastructure, about security, about the application itself. Everything needs to be app-centric. I want to understand exactly if there's an attack on the infrastructure that affects my specific application. I want to understand if there's an attack on my specific application, not on others, that will affect the SLA of my application. Okay, so everything that we provide in terms of application monitoring or SLA monitoring needs to be app-centric so that the DevOps and app owners will be able to manage their own applications. And last but not least, we need to provide 360 degrees visibility. Okay, application SLA plus infrastructure health plus security and cybersecurity health. Everything needs to be provided under one roof, because all of those parameters, all of those areas of responsibility affect the SLA of your application. Okay, so whatever solution you choose needs to be centralized, needs to be standardized, needs to provide information in an application-centric way, and needs to provide information about all the components that affect your application's SLA. So with that, I conclude the part of the presentation, and I think it is a good time to take questions from you guys, the audience.